Hi all, welcome back to the Docker Analogy series where we are learning and mastering Docker. In the last video, we talked about a multi-container app. We were able to divide the existing to-do app into two different containers, namely a to-do app and a data container. The to-do app container had encapsulated the application logic, and the data container had MySQL image running, which was used to store the database or the data that we are generating through to-do application container. So on similar lines, imagine imagine that you have 20-25 such containers running. So on your screen you can see you have an auth container, core container, a catalog, a checkout container, cart, history, Postgres, and Mongo. Like, I'm just showing that you have these containers running. But in a production app, in a big production application, imagine the Amazons of the world, Flipkart of the world, right? You will have many containers running. And if I am supposed to manage them through a Docker CLI or even through UI, or even through Docker Desktop, it's going to be extremely difficult for us to manage, because then you have to go and start each container one by one. You have to either click or execute some commands. If you have 50 such containers, then your life is going to be very difficult. You will have a tough time managing all these containers. And it's just not about containers. Then you have the volumes, right? You need things, you want to debug few certain things, right? And then you want to debug maybe 3 containers in a row, because your flow, application flow, goes through these 3 containers. Okay, so it becomes difficult to be able to handle these containers or manage these containers through the Docker CLI. Now we are looking for a tool which can help us manage these containers. The answer to this question is Docker Compose. Now, what is Docker Compose? Docker Compose is a tool that helps you define and share multi-container application. With Compose, you can create a YML file to define the services, and with a single command, you can spin everything up and or tear it down. I have a small snapshot of what a Docker Compose file looks like. I'll quickly explain what are these alien instructions that you're seeing on the screen. The version at the top is the version of the Docker Compose that we are using. Okay, and then we have the services where we define the containers which are defined or which are needed for our application to run. So we have defined 2 different containers, a database container and an app container. Let's go into the details of this, right? So under database, you have an image, meaning what is the image that you are planning to use. Just like Docker Compose, right? When we run when we use a Docker run, we specify what image you want to use. And if you want, we can also add what is the version of the image that I want to run for the Postgres. If you don't provide it, then it goes ahead and downloads the latest image that is available on the Docker Hub. Then what network we are planning to use. So by default is the bridge network. You don't have to specify. Even if you do, that's fine. Then are you running a custom network? You can choose to do that. You can choose to run a different network. So here we are saying that, okay, this database container should be a part of my network container. And there are other network aliases. If you've gone through one of the DB related container or a multi-container, when we had defined the multi-container app, right? There we had discussed about this network aliases. These are basically aliases or alternate names given to this container, and you can choose to use DB or a database server as a name to connect to this container. So this is a database or a data container that we have defined. Next is the app container. The image that we are using for this app container is my app. Again, this is a made up name. My app container may or may not exist. Okay, it might exist locally as well. Then networks, what networks that I'm planning to use? The my network. I want, let's say, my all my containers to be part of my network. And how, where have we defined this my network? Here is where we are defining the my networks which will be used. So when when we start the Docker Compose, or when we use the Docker Compose, networks will be created first, because this is the dependency, and then the other containers will be run. Now uh, if you haven't if you haven't used YML format, then it might come across as a something, something, a new skill that you have to learn, but it is actually, it is not very hard. You can gain this skills really faster, because the format is self-explanatory. And why YML is such a popular format to write configuration files, and it is heavily used in many technologies, like not just Docker, but let's say defining cloud stack. So for defining cloud stack, you use cloud formation template. Now cloud formation template in AWS has two different formats, JSON and YML. The YML is the most popular there as well. The alternative to cloud formation we know is Terraform. Terraform is again a technology or a tool through which you can define an entire cloud stack in a cloud agnostic way, right? The Terraform is that technology where you can define the cloud stack without worrying about what vendor cloud are you planning to use, be it AWS, Azure, or GCP. There also YML is a popular format, so you can understand YML, why we need to learn YML. Even though I'm not giving a lot of details on YML, go and read about it. It's not very hard, okay? And then you can come back and continue on this video. Even though through this video you don't have to worry about it, I'm going to explain every single thing. As you can see, as we went through this is a very simple to define, right? You have these services, and under services you define the container, so you provide a certain space. And similar to Docker, right? Docker extension we have in Visual Studio Code. Similarly, you will have Docker Compose extension also. Go ahead and download that extension as well. What I'm going to do next is, we had our to-do app, right, where we had two containers and we were running them individually. What we are going to do in this exercise is we will try to use the Docker Compose way of doing things to bring up the same app, okay, so that we can understand the power of Docker Compose and how Docker Compose is a de facto standard to handle the multi-containers app. Let's go ahead and start it. So I'm opening my command prompt. Okay, I'm already present in the code. Let me open the code. Okay, I think before we do that, let's go ahead and install the Docker Compose. That's important. So install Docker Compose, and I don't want dots. Okay, so you can use this link. I will add this into description also. Okay, I want to install this on the Mac. Docker Desktop for Mac chip with app. I have Intel. Okay, so I've downloaded the Docker Compose. No, sorry, my bad. This is Docker Desktop. Let's go down. I think I went to the wrong page, looks like. Installing Docker Compose. This is Docker Desktop. Okay, downloading and installing it manually. Okay, so let's run this step to install the Docker Compose. Okay, installing using the repository manually, right? Let's try this out. Okay, you just have to follow the instructions that I am following, Okay, so let me enter the password. Okay, and okay, I think I did this already. Let me check the version now. Docker compose -1 is version. Okay, so you can see I have the Docker compose version v.23.0. Okay, you can go ahead and try it out. I think there are two different variations are available, right? Both of them will give the same answer. This is the Docker dash compose. I have been using this kind of way of doing things, and this is, I think, another way of doing things is available right now. But yeah, both of them gives the same Docker version. Okay, so we don't have to worry about that. Once we have the Docker compose installed, let's go ahead and use it in our application. So I have opened the getting started app that we have been using all throughout this series of Docker analogy. If you want, you can also go ahead and add the extension. So if you go to extension, you can go ahead and install the Docker compose extension. So right, it will have everything. Let me go ahead and install it. Once this is installed, okay, let's come back to our app, okay, and see how can we do this. Okay, so I'm going to create a Docker compose file. The name has to be docker compose.yml. The extension, sorry, my bad, let me rename it. This is docker compose. Okay, and you can see it immediately recognizes that file. Okay, the version which I told you, right, in the PPD, it's not important. It's just a metadata that you want to use. So we'll start with the real meat, which is services, right? Under services, I had explained you that we are defining we define the containers there. Okay, so let's go ahead and define the containers there. So under services, I will define the to-do app container, or let's name it app. Under app, I will define an image. So image. Now the image that I want to use is node 18 Alpine. This is what we have been using in Docker Compose also. Then what I want is I want to open up the port 3000. That's what we have been using so far. Okay, and using a dash, consider dash as an array, right? So where you can choose to open up multiple ports. Now I want to open up port 3000, but before that I want to just add this so that the mapping becomes complete. Okay, I am adding the local host here, and also so I'm adding the local host here. Okay, and followed by the port, and this is my container port. So host and container, this is what I'm defining here. And then I am defining the working directory. If you remember from the Docker X lessons, that the working directory is where the application gets created under that containers. Okay, so let's define /app as our working directory. Next, let's define the volumes. Now under volumes, right, so there are two ways to create this container. One is through the actual image. Okay, and if I go back here, Docker images, looks like my Docker is not running. Sorry about that. I might have restarted my machine. So let the Docker come back. Okay, it's already running now. Okay, so Docker images, I have this to do app, right? We have been using this version of the image as well, and also we can choose to use this to do app 001 006. So instead of giving this node image, I can choose to use to do app and 0.0.6. okay, I can do that, and then I don't need to do volume mount, but I want to show you something, okay, how we can use the image as well as the code mounting part. Okay, here what we are doing is we are using the base node image like Alpine node image, and we are mounting our code. Okay, so what we are doing is we are mounting the current directory where the code present, where we are mounting this in /app. okay, and then the MySQL container that we are going to create, the data container that we are going to create, we are going to do that through an image. So we'll have both the examples. We have an example where we will get to know how to actually run this in a debugging mode or during your development, so that you mount your code. And also I will show I'll also show example where actually you can use your inbuilt image. Okay, let's continue now. So you define volumes here, and then we know we had set up environment to be defined. So let's define the environment variables now. So some of the environment variables that we had used, so MySQL host was the one. So host name is MySQL, then MySQL user was root, MySQL password was secret, but it's up to us. Then MySQL database was database name MySQL DB is equals to to-dos. Okay, and once we mount our code, right, the important thing is, so if I go to this package.json, right, important thing is to be able to run this application, right? And then we were using the dev as a mode, but there are other ways to do it. So what we're going to do is, once our application is is mounted, so I want to run this application, right? So index.js is through which our application is we want to run. So we will add a command as one more part, okay, one more entry. And wow, this is great. I think this intelligence is pretty great. So it is telling me, okay, based on the configuration that I have, okay, what we want to do is we want to execute a shell script. Okay, under that shell, what we want to do is yarn install and yarn run dev. So it was able to find out that we have a command in package.json, right? So it is doing the exact same thing, right? It is first installing the all the node modules, and then we are running the yarn run dev, which will eventually run this. Okay, the good thing about using this specific configuration is that when you mount the code, okay, you have already mounted the code, and as soon as you change something, right, you would want your container to restart, or container to make those changes available in your container without you having to manually restart it. So this configuration will actually help us do that, and we'll see an example for the same. Okay, now we have a MySQL app container up and running. Next we want to define the MySQL container. Okay, let's go ahead and define MySQL container. Okay, now here what we want to do is we want to use an existing image. Okay, so I think we had MySQL 8.0, if I'm not wrong. Let me open that. So we have MySQL 8.0, right? Let's use this image. Okay, so we'll have two examples. So this is good. Now the image is defined. We want to define the volumes. Okay, we want to store the data. So what we are saying is to do MySQL data, that's my volume, and where I want to mount my MySQL data to this volume. Okay, or I want to map my data which gets created under this directory inside the container to this volume. Okay, what are the environment variables we need? Let's add those environment variables. So MySQL root password is secret. And MySQL database is to-dos. Okay, I think we are good here. both the properties have been added. Okay, the one thing that we missed is actually volumes basically. So under services we defined the containers, right? So you can see the MySQL and app container, and the volumes will be at the same level as services. Okay, and the name of the volume that we want to add is to do MySQL data, right? That's the volume that we added here, to do MySQL data. That's what we defined the volumes. Okay, so when the application or when the Docker Compose starts, the volumes get created first because we have a dependency on the volumes, and then container gets created afterwards. Okay, so let me do docker ps -a. Let me see if there are any containers running. No containers are running. Okay, so we're in a great state now. Then let's do docker compose up. Now docker compose up basically brings up all the containers which are listed here, or instead of saying brings up all containers, I should say it builds the entire stack. So whatever is needed, so be it volumes, networks, we haven't added networks here, but it will create all those dependencies, and then eventually it will create all the containers. Okay, let's go ahead and do this docker compose up. And there is this another option, right, when you do docker compose up. So let me do docker compose help, right? So you have this flag, to run this docker compose in a detached mode. Let me see if I can find it here. Okay, let me try docker compose -help. Okay, so I'm not seeing detached mode. So when you are bringing up docker compose, right? So when I'm writing docker compose up, so it will bring up all the containers as we said, but it will be a part of it will be a child process of my current terminal process. Okay, and I can choose to detach it using -d, so that I can close this terminal without having to close my containers which are running. But let's try both the things. Okay, so I am running docker compose up. So what it did is created my network. So it is a default network it created. Okay, because we haven't specified anything, and then it went ahead and added the volumes here, and then it brought up the containers. It brought up the containers, and you can see here our application started. It started this, and it was actually, so MySQL is ready to use. Did it connect eventually? It says connection refused. Let me see if containers are up. Let me try in other terminal now. I saw some error, but it could be that it could be because of the DB wasn't available, right? Okay, so I'm seeing both the containers to be up. You can see the name of this is the getting started app, and then app1 as the default container name. We can provide the name of the container also, which we haven't given. And then we have this MySQL app, both of them actually running. Okay, and you can see this is mapped to port 3000. Okay, let's go ahead and open the application. So localhost 3000. I'm not seeing it. Give me a moment. Let me see if container is running or not. I'm seeing container to be up. Let me see. Yeah, it is all good. Let me try 127.0.0.1. No, it's not running as well. Give me a moment. I will debug this. This seems to be fine. Everything seems to be fine. Let me see why it's not working. Okay, so I was able to fix this issue. I didn't have to do much actually. I just made some changes into my Docker my code actually, and restarted. Okay, and then when it restarted, it automatically connected. So what happened for the very first time when this container came up right? It was trying to connect to the database, and the database wasn't available because it was also in creation stage. Okay, that's why my app crashed. Okay, but when I did some changes, saved this, right? So when I did some changes like added something, saved it, as soon as I saved it, right, because of the nodemon, it restarted the container and it was able to find the container. Right now it is running in development mode. That's fine. Let's go back and refresh this now. Okay, you can see the application is running. We don't need this also, so local host will work. And then let me add some new atoms. So atom 1, atom 2. Okay, yeah, you can see we are able to make this application work through Docker Compose. Similarly, even if you have 50 containers, right, all your containers wouldn't change all the time, but whatever containers you want to change, you can have many such containers written here and change those specific containers. If you want to debug, mount that code through the volumes, add the specific commands to start your container, and you will be able to handle the big application easily through Docker Compose. So that's the power of Docker Compose. The big advantage of using Compose is you can define your application stack in a file and keep it at the root of your project repository, right? And because it's a file, it can be version control as well, and it can enable someone else to contribute to your project as well. So let's say if you want to distribute this application, what do you need, right? So basically, if I, let's say, remove this volumes for now, right? If I use to do app, for example, 0.0.6, right? And if I give this only file, Docker Compose files, to one of my colleague, he will be able to run this application without any issues, because these images will be pushed already in the Docker Hub through the CI/CD pipeline. So only thing that we need is this specific file to bring up the entire stack. So that's the power of Docker Compose. I hope that helps you understand how the multi-container apps can be managed through Docker Compose. This is a very overview that I have given for Docker Compose, and there are many other things that we will look into Docker Compose. Okay, but I'll stop here. Thank you everyone. Bye.